Good morning, students. You are welcome to our online class. Today we are going to learn new theorem. It is very interesting and important for electrical students. That is Norton's theorem. So this topic is regarding to diploma third semester electrical students. The subject EE 302C. Now, in previous classes we have covered some important theorems like Ohm's law, superposition theorem, star delta conversion theorem, Thevenin's theorem, and now in this class we are going to study another similar theorem is the Norton's theorem. As we know that our electrical energy is a mighty energy. It can easily converted into any other form. At the same time, different energy sources also converted into our electrical form. As we know that energy cannot be created, cannot be destroyed, but we convert from one form to another form. Available energy sources among in the universe, our electrical energy is very easy to convert into another energy sources like mechanical energy, heat energy, wind energy, different of the energy sources with some applications, some machines. Whereas other energy sources available abundantly like conventional sources and non-conventional energy sources easily converted into our electrical energy like solar energy, wind energy, hydrodynamic energy, different of the energy sources. Hence, our electrical system plays a vital role in our daily life. At the same time, our networks also in complex in nature. As we know that in school level, our electrical circuits connected in series parallel only. But once our desires increases, our inventions increases, day to day research and development progresses, then our electrical networks also very complex in nature. In complex networks, we are going to know a particular element characteristics. Then we have to consider total network which has so many number of active sources like voltage source and current sources and passive elements. Simultaneously, we have to consider all things and we have to see what is the current through a element, what is the voltage drop across that element. Hence, we require this enhancement of laws from Ohm's law to Norton's theorem. As you know that we have performed some problems, simple problems with the help of our basic Ohm's law. If branches increases, if number of sources increases, there it is the voltage source or current sources, then we are going to use our Kirchhoff's current law and voltage law. If network configuration is in complex nature, then we use to star delta conversion theorem and converted into simple circuits, then we are going to apply our basic Ohm's law. And if the network is complex nature, then we have the more number of sources, then we are going to know that the impact of different voltage sources and current sources on a particular element. We considered one source at a time, and remaining sources kept aside with its internal resistance in superposition theorem. And further, whatever the complex circuit is represented with simple one voltage source and one equivalent resistance connected in series. Those theorem is known as a Norton's theorem. From this, we are going to calculate a repeated elements which are going to find its characteristics. Similarly, the Norton's theorem, now we are going to learn Norton's theorem. Okay. So, what is the difference between the Norton's theorem and Norton's theorem is similar. In Norton's theorem, what we have seen, so what are the complex circuit converted into voltage source in series with resistance. Similarly, same complex network converted into current source and parallel with resistance. This is a similarity. Let us say one by one in details in this class. So, what is our objectives today? Now, on completion of this period, you would be able to know the statement of Norton's theorem, the explanation of Norton's theorem, and some applications of Norton's theorem, how we are going to solve our simple problems. As you know that, what is this, dear students? You know that these are the different sources. Now we can see this is the hydropower station, this is a thermal power station, this is a wind power station, and you can see here this is a solar power station. From different energy sources, we are generating energy from long distance to the nearby load center. For example, this is the load center. At the same time, we are going to use and commercial and industrial also. Not only for this commercial and commercial, sometimes we are going to use the agriculture also. And so this can be used for transportation, in train transportation, and sometimes we can use for the charging purpose the shipyards. Not only these simple applications, we have the n number of applications of our mighty electrical energy sources. So we have so many elements, so many energy sources and complex networks in between these all elements. Hence, we require some knowledge. Let us take a small example. Whether you are taking the hydropower station or thermal power station nearby one substation, where this thermal power station or hydropower station generating the voltage only low voltage from 11 kV to 33 kV. 33 kV, that is a small voltage. So this voltage is step upped here nearby station transformer. So here itself you can see what are the different elements present in the station. I think you have observed or visited nearby substation, you may found these all elements. Here you can see at a glance, this is a one simple electrical substation, where it has a number of components: circuit breakers, current transformers, potential transformers, power transformers, relay systems, bus bars, AB switches, insulators, different items you can see in the figure. So all are connected in a systematic way. If you observe one line, another line is if touches or nearby each other, then automatically there is a arc, a spark between the two lines. Hence, we have to keep in a systematic way. Otherwise, we may face frequent problems. This physical system is written as per in the form of circuits, electrical circuits. Now you can see we can write this substation into our electrical drawing. So you can see this one. This is a simple electrical drawing where the transmission system, there is a two transmission systems coming from the different places. It may be from, for example, you can take it, this is a one station from NTPC, you can take this is from the Nagarjuna Sagar. And both are supplying input, here supplying the input supply to this system, and it is connected to the interconnected system, and it has so many elements connected, and each element in a systematic way. And we know that R phase and Y phase and B phase, three phases from input, all are connected in a systematic way. Then so you can observe what will happen. The circuit is a complex in nature. In the suppose I want to know this, what is the value of the air, I want to know the current. Then what to do? Then so I want to know what is the current in this branch. I want to know what is the voltage drop, voltage across this one. I want to know what is the power coming and going. So these all characteristics I want to know in a particular branch, particular element. Then how to know this thing? Every time you have to consider, so you have to consider all effect from this supply and this supply and this effects and this effects. Sometimes there is a capacitor banks also in substation and reactors also in the substations. So you have to take all in consideration. But we cannot leave it, we have to find it. That purpose, our scientists are struggled and found the easy methods to find any branch values in the systematic way. Now let us take one simple network. Okay, so this is an electrical network where it consists of one current source, another current source in another direction, and one parallel resistors, another parallel resistor connected, and one voltage source connected in series, another resistance here. That means the current source and voltage source. Here the current source is connected in parallel with just like ideal source, and here also connected in parallel. Now voltage source connected in here series. Now three sources connected in such a way that I want to know that what is the current or what is the voltage drop in R1 with effect of this, with effect of this, and with effect of this. Okay, I want to know what is the current flowing here. I is equal to how much? That is the I1, here represented the I1. And I want to know what is the drop, VAB dash. What is the voltage across the here. If I know the voltage and current, I want to know the power, I want to know the energy also. Okay, so this is a simple circuit. Dear students, you are very familiar about this circuit. What to do? In case of superposition theorem, you are going to apply, first you apply the only current source, replace this one, replace then find the what is the current this one. After that, replace this one and replace this one, apply this one, you find that value. After this, replace this one and with this one find the current. Then the resultant current is equal to what is the impact, what is the current, first case, second case and third case. based on the direction, we are going to find that what is the current in the R1. That is the tedious in nature. So, our scientist named the USA settled scientist, the Thevenins or Nortons found our problems, and they simplified into simple elements. Whatever the complex circuit is diverted, simple formed into the voltage source and one resistance. From this, we are going to find that what is the value in a connected element. Okay, so let us see. So first basic idea of Thevenins theorem. So here see, you can see. So this is what is Norton's theorem. So before going to the definition, so here terminals, students, just you remember this one. Here, so A terminal and B terminal, and whereas this is the circuit is a complex circuit, you don't know what is inside. It may be current source, it may be current source, it may be voltage source. All sources present inside, we can say this is a complex circuit. Okay, complex circuit. Now, I want to know that if I connected one resistance, one load here, I want to know what is the current here. Suppose I connected the R1. Then, so if you remove the R1, I connected the R3. Then, if I connected across the AB terminal, I am going to find that what is the current in the R3 also. If I connected the R4, I can easily calculate it. That means, whatever this complex circuit simply represented by simple, you can see here, simple current source here. So that means this complex circuit represented by current source and with parallel one resistance. So this A is equal this A, this B is equal this B. Whatever the complex circuit converted into one current source in parallel with a resistance. So we can say this is a Thevenin's source. We can say Thevenin's resistance. Now you may get some doubts. Sir, how to find, how we are going to convert this complex circuits which has so many voltage sources and current sources and elements. So we will learn. That is a very easy, dear students. Now, so what of the complex circuit you are going to find that is equal I Nortons and R Nortons we are going to find it. What is the procedure, sir? So you have seen in Thevenins theorem, what are the complex circuit? What you have seen? You find that V Thevenins you calculated. How you calculated? Whatever the load here that is removed, from seeing this one, you are going to find that what is the voltage. That voltage is another V Thevenins. I am correct? Then at the same time, so here by seeing this one, you are going to find that what is the R Thevenins. Whether if voltage source is connected, that is replaced by the its internal resistance. If the current source presents, then represented by the open circuit. That is the R Thevenins. That is the V Thevenins. Similarly, whereas we are calculated in a complex circuit R Thevenins, the similar procedure you are going to apply same procedure in Norton's theorem also. Once again, I am going to tell you that how you are followed rules and regulations to find R Thevenins in a given circuit. Same procedure you can be applied in Norton's theorem also, because R Thevenins is equal to R Nortons. Same. What are the procedure you followed for R Thevenins? Same thing. What is the followed? Just by seeing the open circuit terminals, you find the what is the equivalent circuit. Okay, then okay, sir, we got it this one. Now, how we are going to, what is the relation with the V Thevenins and others? If you know the V Thevenin's, V to R Thevenin's, so I Thevenin's, I current is equal V Thevenin's by R Thevenin's, we are going to the I Norton's, nothing but that thing. Or you want to find individually, then what to do? Simply find the, so simply you, in this case, in Thevenin's theorem, you have opened A and B terminal. In this case, you short it and find the what is the current across AB terminal, shorted terminal. That is known as the I Norton's. Okay. So this is a basic idea. If you have the further, if any doubt, let us see in this one. Now you can see. So what is the Norton's theorem here? Now you can see. So dear students, once again I am going to explain. So here, for example, this is a, for example, you can take it. Here is the Thevenin's theorem, known value. Okay, Thevenin's. This is the Norton's. What to do? Norton's. So here, for example, this is a one source, this is one resistance, here is one resistance, and here is resistance, and here is a, for example, resistance I connected here, terminal A and B. Okay. Now this is a one source I connected. Now similarly here also we are, what you are going to connect here is also resistance connected here, and this resistance connected here, here is connected resistance. Okay. So here also you connected resistance. Now same circuit, here what is happened in Thevenin's theorem? First this circuit, whatever this circuit, this total circuit is represented by, what is it represented? Just represented by this voltage source and one source. This is the terminals. This is A, this is B. So then we can say this is the R Thevenin's, this is the V Thevenin's. Okay, plus minus. This is represented this diagram. Okay, how we are calculated R Thevenin's and V Thevenin's last class we have seen. Now similarly here also, so this circuit is converted into, so what is this one? Similarly here also we are connected the one current source here. The current source connected in parallel with one resistance and connected this terminal to A, this is the B. This we can say R Norton's, okay, R Norton's, and this is the I Norton's. Okay, so what is the difference? Here voltage source and resistance connected in series, and here is the current source, resistance connected in parallel. So this is known as the Norton's theorem, and this is known as the Thevenin's theorem. So how we are going to calculate R Thevenin's? Here R Thevenin's, how we are going to calculate it? Once again I am going to tell you. So here R Thevenin's is, so whatever the circuit is given, okay, you can see here. So whatever the circuit is given, so you are going to calculate, for example here, once again I am explaining you what happened. Okay, so now here how we are going to calculate it? So I am going to write it. Okay. Now, so here how we are calculated? Similarly, you know the everything, the process, that is R Thevenin's. So here what? So by seeing here, you are going to calculate it. So R Thevenins. First you calculate the R Thevenins. So how you calculated? So voltage source is shorted, and what are the resistance? 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 This is the terminals. By seeing here, this resistance, this, so these two are connected in parallel, and this are connected in series. That is called R Thevenins. Okay. Similarly, here Nortons also similar you can connect. So whatever the voltage source is connected here, and resistance connected here, and here this resistance and this resistance connected. By seeing this one, you are going to get that same value. This both are parallel and series with series. So that means here R Thevenins is equal to the R Nortons. Same procedure we are going to apply. Okay, whether is the voltage source presence, is short it. If internal resistance presents, then indicate it. If the current source presents, just open it. That is already you know. Now the first case. On second case, in this case, so how to calculate second? Here how you calculated? V Thevenins. Okay, so here V Thevenins I want to know. Here I Nortons I want to know. I am giving some basic idea regarding between the two theorems. If you know the perfect in Thevenin's theorem, so this is a very simple to understand Norton's theorem. Okay, so resistance point of view both are equal. Now I am going to do this one R Thevenins. From this one you can see here what is happened. So by seeing this side, what is happened? I want to know what is the voltage across the VAB, that is equal to VAB I want to know. So VAB how you are going to calculate? So here whatever the AB is removed, then I want to know that what is the voltage now. Here you can see it. Here you can see it here. I want the voltage across this here VAB I want. If I know the voltage across here, if you know the voltage across here, so this total voltage is nothing but VAB. Okay. So how you are going to calculate this one? So that can be calculated by this current. Here what is the current now? What is the resistance? This is open, this is the open, only whatever you apply this circuit. Then voltage we know, here resistance R1, R2 you know, and R3 and R4 here. So R3 and R4 is an open circuit, there is no current flowing through this, and only simple R1 and R2 is current flowing. Then I want to know that current I is equal to V by R1 plus R2. Okay, so that is the current flowing here. If you know the current, same current is flowing here, then I can calculate what is the current here, what is the drop. Okay, so that is we are going to find that what is the voltage across this one. Similarly, here current theorem in Norton's theorem. So you are going to find that, so simple, just you short it here. In this case, here just you shorted the value. Then find the current here. How you are going to find it? Now if you are shorted, what will happen? So this and this is connected in series, and both are connected in parallel with this one, and the total is connected in series with this one. Then we know the R total. Okay, R total we know. Then we know the V by R total, we are going to get the I current. So whatever the current I know this. Then I want to know the current across this one. So if you know the total current, I is I into this value by this plus this value, we are going to get this current. That current is known as the I Nortons. Okay. So this is a simple concept, dear students. Don't panic, don't confuse. So we will see in step by step with few examples. Okay. So here is a basic concept. Now let us see what is Norton's theorem. So what we have discussed in introduction, same is represented in the figure form. Okay. So whatever this complex circuit is represented by simple just one current source and one resistance connected in parallel. So whatever the circuit is equal to this one, that is the Norton's theorem. Now let us see one example step by step. So let us see what is the definition first of all. So here you can see this is our master Norton's. It belongs to USA. What he says? So Norton's theorem says that, it states that any two terminal linear network, what is a linear network? Which obeys the Ohm's law. You know it. Okay. So it states that any two terminal linear network can be represented with an equivalent network which consists of a current source in parallel with a resistor. It is known as a Norton's equivalent circuit. Just we discussed. Okay. Now a linear circuit may contain independent sources and dependent sources and resistors. So last class we have seen what is the dependent source and independent source also. Okay. This is the Norton's theorem. What it is saying? So any two terminal network can be represented with an equivalent network which consists of a current source in parallel with a resistor. Okay. So now you can see here, you can see if a circuit has a multiple independent sources, dependent sources and resistors, then the response in an element can be easily found by replacing the entire network to the left of the element with a Norton's equivalent circuit. That means here, for example, you can see, so here this is a load is connected. I want to know that what is the current, what is the voltage in the load, and the load is supplied from this network. The network consists of so many independent, dependent, that is the voltage source or current source or resistors. So many complex circuits connected here. From all sources we are going to get some supply to our load. So how much load is taking current from the source, I want to know from this complex circuit. So the total complex circuit is represented by the simple this value. This is the same. So here I connected the same load. Thus this complex circuit is converted to the simple current source connected with one resistors in parallel. So here I can know easily. Okay. So dear students, don't confuse. I will give the one example. Okay. So here what we are going to see here is that, for example, let us assume now at weekend you are going to attended one dhaba nearby city. You are going to attend the dhaba. You may be ordered chicken 65, chicken manchuria and chicken curry, chili chicken, different items you are going to order. Within 15 to 30 minutes the order will comes to your table. At the same time, you are going to order the chicken fried rice, chicken biryani, everything in form of these all items. For example, within 15 to 30 minutes, how we can manage to supply whatever you are ordered. So, is it possible to in our home also? Our mother may not be supplied 15 to 30 minutes this so much of items in a less time. And at the same time, another table, another person may be ordered the different chicken, ginger chicken, different all items. He is also going to give the same items within this period 15 to 30 minutes. That means, so before opening to this dhaba or hotel, he has made some preparatory work. He will take the chicken and cleaned, boiled or different process he taken and keep ready for raw materials. Boiled chicken is kept for ready and different shapes also ready and different ingredients also kept ready. Now, based on the table order, table 1, table 2, table 3 orders, you will take the table 1 chicken 65, you will take the same whatever he previously boiled, fried, half boiled chicken will take, and that is fried by adding the ingredients. He will supply that to the within 15 minutes to the table. And in second table, ginger chicken, he will take the same half boiled chicken and prepared will give us. Third table, you will take the chicken tikka. So, we will take the same chicken and add the different ingredients, he will give this one. Within 15 to 30 minutes, he will supply all varieties to the consumers. That is a technique. But what he has done? He has prepared pre-preparatory work. Some amount of the chicken pieces, half boiled, half fried and masala, everything is kept ready. Now, based on this one, table is prepared. So, this all preparatory work is nothing but our complex circuit. What the table 1, table 2, that is the elements we are going to find. Table 1, this value, same work. Table 2, replace this one, you connect to the table 2, then you prepared. Table 3, you replace this 2 and table 3 connected. So, this whatever this one is known as a complex circuit. So, similarly, our Norton's theorem also same thing. Okay. So, what is happened? So, whatever the zigzag complex circuit, all the circuit is made into, so this circuit here connected the some resistance R1 as a 21 ohms. Now, what will happen? So, if I know this value all represented by simple one current source and resistance connected here, then I am going to connect this same R1, that is called 21 ohm. I can easily calculate. So, based on, because this is a current and this is a resistance, both are parallel, then based on the current division I can find what is the current in this one. If instead of so instead of 21 I want to know that 42 ohms, simply remove it, connect it to this one, find the immediately, simple one step. So, because current division method we are going to find the, I want the another resistance, 50 ohms resistance I require. No problem, you connect the 50 ohms, find the same current division method. So, how we are going to find here? So, simple here, how we are going to find? For example, you take the, this is a current source, maybe 10 amperes, and resistance maybe here take the for example 50 ohms. Now terminals is ready. Okay, so now I take in the first table, you want to know that 10 ohms. Another table I require the suppose 50 ohms. I want to, if I connected the first terminal, that is equal to 10 ohms. How you are going to calculate? So because 50 and 10 is connected in parallel. Or I can know what is the current here, 10 amps. So this current is the, for example, I1, this current is the I2. I want to know that what is the current. Simply I2 is equal to basic formula. What is the total current? That is called I into opposite, that is called R1 divided by R1 plus R2. Simple circuits. So already you know that basic things. So what is circuit this here? This is the current, this is the R1, this is a R2. Okay, now based on this one you are going to find that what is the value. So this is for example R1, I1, this is the I2. Okay, so what is the base? What is the formula basic? You know the in past previous classes. So here I1 I want to know that. So what are the current? I into I want the I1 in R1. So give the preference to the R2 by what is the resistance? R1 plus R2. I can easily calculate. What is the I2? I2 is equal to I minus I1, or I can calculate here total current into I2 I required here. So give the preference to the opposite R1 by R1 plus R2. So this is simple circuits already you know in first level. Okay, same concept we are going to apply here also, simple two circuits. So what you have seen here, now this circuit. So first case is connected, what is connected? 10 ohms is connected. Now what is the value? I1, what is the current? 10 amperes into R1, what is the R1 is the here 50 ohms divided by here R1 plus R2, 50 plus 10, okay, 60 ohms, 0, 0, okay. So 50 by 6. So 6 ones are 6 8s are. Okay? No. Okay, so 48, nearly 40. So nearly 8 amps you are going to get. Okay, 8 amps, nearly 8, some values are going to get. Okay, now if I connected this 50 ohms, what is the value now? Now you can see the 50 ohms is connected. Instead of here you connect the 50 ohms. What is the current? Same current. I current is equal to I1, that is the current is equal to, total current is equal to I50 current is equal to, what is the total current? 10 amps into what is the resistance here? 50, same 50 by 50 plus 50, that is equal to 100. Okay, now 0, 0, 0, 0, that is equal to 5. So in previous case 8 amperes when it is connected the 10 ohms, if you connected the 50 amperes then we are going to the 5 amperes. Suppose I want to connect the another resistance. At a time I am going to get the what is the current in a element which is connected to the across the terminals A and B. This is a ready-made terminal. This is the beauty of Norton's theorem. Okay, so how you are going to calculate it? This is a simple circuit. Okay, so dear student, you do the problems, then you can enjoy it. Okay, so let us see our theorem first of all, the basics. Okay, now, so what you have seen here, whatever this complex circuit is represented with this one. Okay, only current source and resistors in parallel. Now let us do the simple how to find the orthogonals and I Nortons. Let us see. Here what is happened? Any two terminal active network when viewed from its low terminals can be replaced by a single current source in parallel with a single resistance, that is Norton's equivalent circuit. That single current source is called a Norton's current source. So we can say single circuit, whatever the single circuit you can see here. This is the one circuit. So the single circuit, that is equal to, we are going to write it here, single current source. This is a current source. So this source is known as Norton's current source. Resistance which is connected in parallel to this source is known as the Norton's resistance or Nortons. Okay, so this is the meaning of any two terminal active network, this network A, B, two terminals. When viewed from its low terminals, this is a load, we are viewing this one, can be replaced by a single current source in parallel with a single resistance. The single current source is called Norton's current source and resistance is called the Norton's resistance. Okay, so these are the equivalent. This is a two terminal circuit. This is Norton's equivalent circuit. Okay, now we can see represented this one. Okay, let us learn how to find I Nortons or Nortons. Okay, so dear students, some of the students maybe get the bore, but some of the poor students may not be followed. That's why I am repeating each and every technique here. Please bear with me. Okay, so first you learn the concept, after that you could do the n number of problems. Okay, so here this is the basis circuits. It helpful to good electrical students. Now to find the Norton's current, here I want to know the current here. What is the processor? First, so you can see here there is one circuit. So here one circuit is given. What is the circuit? So for example, this is circuit is given. What it consists? It consists of the voltage source, that is equal to E. It has the resistance R1. It has the resistance R2, and here is the load resistance connected here. Okay, so one circuit is given. Now what is happening here? You can see here. Sorry. Now here I want to know that what is the IN. I want to know that this is equal to IN. I want to know. IN is equal to I short circuit for this circuit. So whatever the circuit is given here, just this is given, this is given, here is the terminals. Now here is connected the load resistance. Okay, so what is the circuit here? This is the R1, this is the R2, this is the E circuit. Now I want to know that what is the I in this current, that is equal to IN. So for this purpose, first your aim is to short this terminal. Simply short it. This is a A, this is a B terminal. Short it. Then find the what is the current here. That current is known as this IN current. Okay, short it. If it is shorted, what will happen here? In this case, R2 becomes to 0. Okay, here connected the resistance value, here connected the shorted. What is the value of this one total? That is equal to 0. Then so this circuit becomes to the only this resistance, this one, and this connected, and is connected here only. R1 connected E. Then what is the value you are going to calculate? Okay, so that is the current, simply shorted, and this I am going to find that what is the current. That current is equal to IL. Okay, now that is the procedure. After knowing the current here, now let us do the R Nortons. For the same circuit here, you can see here, for the same circuit, what is happened? So, what are they replace the voltage source battery with its internal resistance. If it consists internal resistance, just represent it. Here small r is given, you can see here. Small r is the internal resistance. That means the circuit now is represented by this one and is connected this one, this is connected this one, and so this is A terminal, this is B terminal. Now we can see here. Now what is happened? This small r, this is R1, this is R2. Okay, then by seeing this one, so this R capital R1 plus small r1 parallel with R2. Simple. That is equal to R Nortons. Okay, so here calculate R internal. Now, so what happened? So whatever the circuit is reduced from this circuit. Okay, so this given circuit is a simplified circuit. So your aim is to convert to this circuit. Okay, this is the same, but whatever the complex circuit is represented by current source and one resistance connected in parallel. Okay, so that is your aim. Now, so how we are going to calculate it here? So simply calculated the basic theorems, series parallel circuits. Okay, so now here calculated so low terminals, VL and power. So how this is after knowing this one, so IL, the load current here. Okay, so what is the load current? IL. IL is equal to what is happen? This and this is parallel. Okay, so both are parallel connected. So that is the total current. I want to know the current. This current is I want to know the current I. Simple parallel circuits. So this connected, and this is connected to the here I. Here R Nortons, this is the RL load. Okay, so I want to know that what is the current here. What I want the current here. IL I want know. So what is the IL? IL is equal to total current I into opposite, that is equal RN divided by RN plus RL. This is the formula we are going to calculate. Okay, simple. And VL. So VL means, so we know the IL and RL, so that is equal, simply can write it. So V into I, so we are going to get this VL. Okay, power consumed, power is equal VL to IL. We know the VL, we know the IL, then we are going to calculate this also. Okay, dear students, how it is easy. Okay, please do the problems and enjoy the problem also. Now let us take one problem, mathematical problem. Now up to we have seen only theory part. How to do R Thevenin or Thevenins or that equal to R Nortons. How to find Norton's current. Okay. Now based on this knowledge we are going to do one problem. Let us do. So here is one problem is given. What is that? Using Norton's theorem, calculate the current through 15 ohm resistor in the circuit given figure. Okay, so for this one I can do manually first, after that you can see the step by step. Okay, so here I am going to do one problem. What is the problem is given? Simple problem is given such a that here one voltage source is given. Okay, here voltage source is given and here current is one resistance connected and here another resistance connected, here some internal resistance also connected and here connected here such a way that, and here terminals, here A and here B terminal is connected and load here connected the another, that value is the 15 ohms. Okay, here 12 ohms, here the 3 ohms, this internal is equal 1 ohm, voltage source is equal 24 volts. Okay, dear students, similar whatever the problem is given. Now I want to know that first calculate, first step calculate or Nortons or Thevenins. This is the first step, you remember. For this purpose, so simplify this one, whatever the sources connected by seeing, remove this one. Okay, so now I am going to remove this one. This is simplified here. So this voltage source, what are the sources are removed, represented by internal resistance. Now here 3 ohms resistance, 12 ohm resistors connected here and terminals here A and terminal B. Okay, you can see from this one. Okay, you can see here, this is a I, you can see here. So what is happened? This is a 1 ohm, this is a 3 ohms, this is a 12 ohm. Now by seeing this one you can see it. So 3 plus 1, that is equal in series. Okay, now what is happening here? 3 plus 1, 4 ohms. Now 12 ohms connected here. Now is connected to the AB terminals. Okay, now what is the value? Now this value is equal to resultant. You can see this one now. Now this value is equal to 4 into 12 by 4 plus 12. Okay, that is equal to 4 into 12 divided by 16. Okay, 4 ones are 4 fours are 4 ones are 4 threes are, that is equal 3 ohms. That means here RAB, or we can say the R Nortons is equal to 3 ohms. Okay, have you got it? So this is calculated now. The first step we calculated equivalent resistance seeing from open terminals. Okay, now first step is done. What is the second step? Second step is the, so please see for the voltage here shorted, current, if the current source open it. Here voltage source removed and in place of voltage source we connected the its internal resistance 1 ohm is given and 3 ohms is connected in series, 12 ohms here connected. By seeing here what will happen? So this 3 plus 1 is connected in series, that is the 4 ohms, and 4 plus 12 is connected in parallel, that is simplified into we are going to get the 3 ohms. That is known as the equivalent or AB or Thevenins. That is the first step. Now what is the second step? Second step we connected the I Nortons. I want the I Nortons across AB terminal. For this purpose, just to simplify the circuit. Here what is happened? So here you are going to write the same, this one. So same one you write it, 3 ohms, 12 ohms, here 1 ohm connected here. Okay, so the terminal A This is the B. Okay, so what is the 12 ohms? 3 ohms, 1 ohm, voltage 24 volts. Okay, now based on your basic knowledge, now for this purpose you are going to short it. Simply short this terminal. Once shorted, what is happened? Here 12 plus this is shorted. So simply this circuit is reduced to, you can write it here. So this one, now this one, and you are connected this one. Okay, so what is this one? Here is the 3 ohms, this is the 1 ohm, this is the 24 volts. 12, this is becomes the 0. Now it becomes the 0 because shorted. Now, so now what will happen? 1 ohm and 3 ohm is connected in series. Now what is happen? So what is the current? I want to know the current. I is equal to V by R. So what is the V? The 24 volts. What is the R total? 3 plus 1, 4. 4 ones are 4 6 are 6 amperes. That means here 6 amperes current is coming here. Amperes current is coming here. Now I want to know that what is the current flowing, 6 amperes. Now I know this one current. Okay, so I want to what is the current flowing here. Same 6 amperes coming. Okay, 6 amperes current coming here because it shorted. The short circuit current is the 6 amperes. So IN is equal 6 amperes, because you can see it, the 6 amperes coming here, same current is flowing, shorted. This is the A terminal, this is the B terminal. So what is the IAB is equal to, that is equal to IAB, that is the I Nortons. Now from this one we got it. So IN is equal to how much current? 6 amperes. So based on this one, you just rewrite the equation. What is the equation now? So this current source is equal to 6 amperes. So plus minus in direction, you can see the direction of this one. Okay. Now what is the resistance connected? 3 ohms. Now this terminal is the A, this terminal is the B. Okay. Now it is ready to take any load. What is the load is given? Problem. In problem, the load is given how much? What is the value is given? Is a 15 ohms is given. Here connected the 15 ohms load. Now I want to know that what is the current in this one. So what is the current now? So here the current is coming here. What is the current here? Now the current is the 6 amperes. I want to know that what is the current here. So simply that is equal to I at 15 resistance is equal total current I into R1 by R1 plus R2. Here R2 is R load, Rn1 is called N, and this is the N. Okay, this is called ISC. Now what is the current is given? IS 6 amperes into what is the here? Rn, that is called 3 ohms. Here 3 plus 15, that is equal to 18. 6 ones are, 6 threes are, 3 ones are, 3 ones are. That is equal 1 ampere. So when if you are connected 15 ohms resistors across the A and B terminals, the current is flowing through is 1 ampere. That is the required. No? He asked how much current. So 12 ohms resistor. Find the current flowing through the short 12 ohms in parallel with a short. That is the current. You are going to count that is the current. Okay. This is the problem. Now, okay, dear students. So once again, I am going to explain with the step with animation. You can see. Okay. What you have seen first. Whatever the problem is given. Here you can see whatever the problem is given, simply, so you take in the first step, we calculated, so you remove this load resistance, kept aside, and find what is the R Thevenin's by seeing these AB terminals. So we carry this circuit is simplified into this one, we calculated this value. Now in second step, the short the AB terminals, okay, AB terminals, short it, find the current through the AB terminal, that we have got the 6 amperes. Now based on the current source, based on the this R, we build another circuit, equivalent circuit, that is 6 amperes parallel with the 3 ohms connected, and AB terminals are ready to take any load. Now if the given load is a 15 ohms connected to AB terminals, then we find that what is the current in a 15 ohms is nearly 1 ampere. Okay. Suppose I want to connect the, instead of 15 ohms, I connect the 50 ohms I want to, then simply connect it 50, then you are going to calculate what is the current. Now if you connect the 50 ohms, what is the value? 6 into 3 divided by the 50 plus 3, 53. Then this is the current. Suppose I want to know that instead of 50, I want to know the 100 amperes, 100 ohms. Then simply 6 into 3 divided by 100 plus 3. Okay, what is 100 plus 3? 100 plus 3 is the 103. So we are going to find that current in the circuit. That means this may be chicken 65, this may be chicken tikka and ginger chicken, everything. Simple, once you have calculated this boiled chicken. Okay, so this is a basic idea of calculating problems. Okay, you can see here. So how we are going to animation here, solution. So to find the here in problem, we calculated, first step is the calculated the Norton's equivalent current. Okay, anyway, no problem, just here what he has done, simply shorted AB terminals, you can see here, shorted AB terminals. Okay, then so remove the load resistance, remove it, and short circuit the load terminals as shown in the figure. Find the current flowing through the short value, that is the 12 ohm resistor in parallel with the short as shown in the figure. Now what will happen? So 12 ohm resistor will also be short circuited. Therefore, the circuit will be as shown by, so reduced this one. Now what is the IN, the current AB across the total voltage by total resistance. So internal resistance 1 ohm and 3 ohms you connect to the 6. So previously we calculated the 6 amperes. Okay, this is the I Norton's equivalent, we got it. This is equal to current 6 amperes, that is equal to I Norton's current. That is the first step. Okay, now after second step, so whatever this one problem, now what is the second step? So second step is that we are going to calculate the resistance. Replace the battery with its internal resistance. Okay, here the source 24 volts battery is replaced with 1 ohm resistor, you can see here. Okay, now this and this is connected in series. So open circuit load terminals are shown in the figure. Yes, we opened this one, load also. Now calculate the resistance of the circuit as viewed from the open circuit load terminals. Now when we look into the circuit as shown in the figure from the open circuit load terminals, from here we are seeing from here 3 ohms and 1 ohm resistor are connected in series. Simple circuit already. The combination is in parallel with the 12 ohms. Therefore, the total resistance is equal to the 4 into parallel with the 12 ohms. That is, we are going to the 3 ohms. Just we calculated previously. So that means we are connected the R Norton's is equal 3 ohms. Okay. Now the total circuit represented, now you can see we calculate the current source of 6 amperes, resistance connected 3 ohms, but with is a Norton's theorem you have to connect current source with the resistance in parallel. So this is a equivalent complete circuit. Okay, so replace the given network with the Norton's equivalent circuit as shown in the figure. So IL is equal load current. What is the load current here? IL is equal, you can see simply whatever the current IL is equal IN short circuit current into RN. So this is RN, okay, divided by RN plus RL. So we are going to get this value. What is the value? That is nearly we are going to 18 by 1 ampere. Previously we calculated 1 ampere. Okay, so this is a simple circuit. So dear students, now you calculate one thing. I am going to give the one homework for you. Please try it. I will give the hints also. Let us do the another problem. Here another problem. What is the problem is given? So here one voltage source, 2 ohms connected, 6 ohms, 3 ohms and AB terminal. He is asking what is the current across the IN, 2 amperes, how you are going to get it. Can you do it? So shall I give some hints to you? Okay, so do it very quickly. Now, what is the circuit is given? Simply 2 ohms, 6 ohms. Now internal resistance is given 3 ohms, A, B terminal. Okay, it's a 12 volts. Here 12 volts is given. This is a 2 ohms resistor. Here is a 6 ohms resistor and 3 ohms resistor is given. This is circuit is given. I want to know that what is the short circuit current, equivalent circuit I want to draw it. This is our aim. Okay, what is the current source? What is the resistance equivalent? I want to know that. So here I want this is required. Then first you calculate as per our required. First step is what is the step first? So first step is find RN. Second step is IN, you find it. Simple. Okay, then that purpose I am going to equivalent resistance. That purpose I am going to write this equation once again. So equivalent RN purpose I can this shorted. Now this is 2 ohms, 6 ohms and 3 ohms connected here. Okay, this is A, this is B and 3 ohms. Here is 6 ohms. This is 2 ohms. Now 2 and 6 are connected in parallel. Okay, so that equivalent resistance is equal to 2 into 6 divided by 8 and connected in 3. Okay, so that is 2 6 12. That is equal, we are going to get 12 by 8 plus 3. 4 2s 4 3s. Okay, that is equal 3 by 2 plus 3. So that is resistance. 2 6 plus 9, that is 9 by 2. So that is equal to, we are going to get 4.5 ohms. This is a resistance or Nortons. Or Nortons is equal 4.5 ohms. We got it. What is the value? 4.5 ohms. Okay, what is the second step? Now for the second step we are going to calculate. Okay, second step simple. So just you write the equation. Now so what is the, you are going to current, simply short it. So voltage source, resistance 6 ohms, now 3 ohms and this is a and B terminal. Okay, simply short it. 3 ohms, 6 ohms and 2 ohms and 12 volts. Now I want to know what is the current here. Okay, now for this purpose you calculate the equivalent resistance. Now what is the equivalent resistance? You are going to find it. So here, so this equivalent resistance you are going to find it that is equal to, so 3 into 6, so that is equal to R total. R total is equal to, it's a series, this two are parallel, so 3 into 6, 18, 3 plus 6, 9, plus 2, okay, that is called 9 ones are 9 twos are 2 plus 2, 4 ohms. Okay, now what is the current? I is equal to V by R total. So V is equal to 12 is given, and R total is equal to how much is given? R total is, we got it, 4 ohms. 4 ones are 4 threes are. So 3 amperes. That means the current which is coming from the source is equal to how much? 3 amperes. 3 amperes is current coming. Now I want to know that what is the current here, because same current is flowing here. Okay, by current division method I am going to find that what is the current. IAB is equal to total current how much? 3 into what is the resistance here? 6 divided by 6 plus 3. Okay, 6 plus 3, that is equal to, so 3 into 6 divided by, okay, now 3 plus 9, the 9. 3 ones are 3 threes are 3 ones are 3 twos are. That means 2 amperes. So this is a 2 amperes current is flowing through the AB terminal. So that means here we got it. This is also called 2 amperes. So resistance is equal to equivalent resistance 4.5 and current is equal to 2 amps. So we can represent this one with a simple source. This is called current source. So 2 amperes. Now here is a voltage, that is the resistance 4.5 ohms. Now terminal, this is called this terminal A and B. This is a required problem. Okay, if you are connected to any resistance here, you can easily calculate what is the current. Okay, dear students, you do the same problem. Okay, I think you got this idea what is this theorem. Okay, so now let us summarize what we have seen in this class. I think you have this experiment in your laboratory also, Thevenin's and Norton's theorem trainer. So trainer consists of this complex circuit, and you are going to calculate. You can see here, this is the circuit. So simple. So this one is the voltage source, one is the current source. If the current source is connected in parallel, then you are going to the Norton's theorem. The voltage is connected with this one equivalent, you are going to Thevenin's. Now in this case, can you find that what is the orthogonal? You are going simply here by seeing this one. So you are going to find the equivalent resistance. What is the value? So we are going to get the 2 kilo ohms. Equivalent, we are going to 2 kilo ohms. That's why 2 kilo ohms and 2 kilo ohms is written. Okay, so this is our one theory. So what we have seen in this class, so let us summarize. So in this class we have seen that the statement of Norton's theorem and explanation of Norton's theorem and the application of Norton's theorem. Based on this one, we have performed a few simple problems. Okay, so do the remaining problems, and if you have any doubts, best ask in the next class. Thank you for listening.